Hello everyone, welcome back to my channel Take Explain Simplified by Arojit. My name is Abhijit Datta. First of all, thank you all my colleagues and friends for their valuable feedback. I hope on this video sound quality has improved. So let's start. So on this video we will discuss about SD-WAN in more details. So this video probably will have 2 or 3 parts. So stay tuned for all the videos. So in this first part, we'll discuss about SDWAN architecture. So on this video, we'll have these below topics. We'll discuss about SD-WAN architecture, control plane versus data plane in SD-WAN, orchestra, overlay and underlay network concepts, OMP. However, the rest of the we will discuss about SD-WAN architecture only on the first video, and the rest of the topics will cover in upcoming videos. So SD-WAN architecture is a virtual WAN architecture that allows enterprise to securely connect users to the applications using any combination of transport services that includes MPLS, broadband, internet and LTE or 5G services. So what it does, it decouples the network control plane from the data forwarding of the from the data plane and applies a software-based intelligence to dynamically route traffic based on application type, business policy, and real-time network conditions. So this architecture follows a three-plane model. One is the management plane, which basically does the configuration, orchestration, and the monitoring part, which also we call as orchestrator. Then the control plane, which is the working on policy distribution, routing intelligence, which also called as controller, and the data plane, which actually sends the packets forwarding and does the encryption task as well, which will be on the edge devices. So that only we have mentioned here. So in SD-WAN, it's a logically designed of software-defined wide area network that separates the control plane and data plane. It defines how network components like controller, orchestrator, and edge appliances interact to create a secure and efficient connections across diverse and transport link, and it provides the framework for applying policy and managing traffic, integrating with cloud or data center environment. So here is the typical SD-WAN architecture, which shows that how the multiple branch offices, data center and cloud services are interconnected using different type of WAN links. So what are the main topics we have here? So let's see. So at the left and right side boxes, we can see they are the branches, and each branches are connected to SD-WAN fabric using multiple WAN connections. For example, MPLS, cellular, broadband, etc. Okay, and then we have the data center, which is here, and this data center is the core enterprise network where critical business application, databases, services are hosted. So this also connected to the branches through the WAN links for redundancy and optimization purpose. So these are the connectivity we have. And then the next part we have is the internet or the cloud. So in the cloud part, we have the services, service provider and the SaaS applications like AWS, Google Cloud, Azure, and what SD-WAN does, it allows branches and the data center to directly and securely connect on those cloud applications. And how it does, so the connectivity that follows the green and purple lines that we have here is the WAN transport connections. Okay, so green are for the MPLS, the purple are for the cellular or 5G, and the blue for the broadband connections. So each branch and data center uses that SD-WAN edge devices to dynamically choose the best path for each application based on real-time conditions. So we have the edge devices connected all here, and based on the traffic and dynamic path selection, they can select whichever path is more suitable for them. Okay, so how SD-WAN work on this setup? So what SD-WAN work here is they will first do the dynamic path selection. So traffic can automatically switch between MPLS or the cellular part or between broadband as well. So based on their performance metric and based on the load, everything. Then we have the main part of SD-WAN is centralized control. So policies are managed from a centralized SD-WAN controller, which defines how traffic is prioritized, routed, and how the security will be measured. Okay. And next part is the cloud optimization. So SD-WAN can send SaaS traffic directly to the internet instead of backhauling it to the data center, improving the speed and efficiency. And security, last part is the security and visibility. So SD-WAN provides the encrypted tunnel, integrated firewalls, and monitor across all the links, which provide more security and visibility. So in summary, branch office location using SD-WAN to connect to data center and cloud data center centralized enterprise applications. Store the cloud provider SaaS and IaaS platform access via SD-WAN as well, and they can use any of the available path. It could be either MPLS, it could be either cellular, or it could be either broadband to follow the traffic, and that will be done by the SD-WAN controller, which path it will be selected based on their redundancy and performance and all the details. Okay. Now on this slide we will discuss about the SD-WAN components. So, and how what are the SD-WAN main components and how they interact to form a centralized SD-WAN format. So in SD-WAN the main components are, first thing is the SD-WAN edge, which is at the bottom layer, or the physical. These are the physical or virtual devices located at branch offices or data centers, and what are their function? To establish a secure connections, okay, between sites by using any type of connectivity. So it could be MPLS, broadband, or wireless connectivity as well. And it performs traffic steering, encryption, and quality of service enforcement as well. So for example, an SD-WAN edge device at each branch connects securely to the other sites and the internet as well. Then we have at the middle layer we have that SD-WAN controller. So that is the centralized management plane of that SD-WAN, and its functions are to manage all SD-WAN edge devices and their gateway, and it applies policies, routing rules, security configuration across all the network, and it collects analytics and performance metrics from the edge devices to monitor it further. So especially it tells the edge how to behave, and but does not forward the traffic itself, but it shows the edge devices how to do it. Okay. And at the top layer we have the orchestrator. So it's the highest controller layer of the SD-WAN hierarchy. So its functions are handles the life cycle of service orchestration, deployment, configuration, automation of SD-WAN, and all the related services. So it provides the management GUI based or API based interface for administration. So it ensures scalability and coordination between multiple controllers. So it's think of like it's as a brain, and that automates and simplifies the large scale operations. Now in this picture, as you can see, we have orange lines which shows, let me just mark it here. So these are the orange lines here, which shows that tunnel and virtual connection. So these are the encrypted overlay tunnels that connect SD-WAN edge across the internet or MPLS. So it enables secure communication between sites regardless of the underlying transport network. Now the C or the MPLS part, this one, so it refers to the customer edge devices or the routers that connected to MPLS one, and it shows that SD-WAN can integrate with existing MPLS infrastructure as well. So in summary, the SD-WAN edge routes and it secures the traffic, creates a encrypted tunnel between branches and data centers, and controllers, SD-WAN controller, it centralizes the policies, routing and management, cloud, and then orchestrator, it automates the life cycle of management and deployment of cloud and the service provider environment. So this layer design allows SD-WAN to be a centrally managed, easily scalable, and transport properly. Okay. So on this slide, we have that architectural planes and the key mechanism of SD-WAN. So SD-WAN solutions are often mapped into a distinct logical planes. So it's data plane, control plane, management plane, and orchestration plane. So first one is data plane. So data plane is responsible for real-time forwarding of network traffic based on rules received from the control plane. What control plane does, it maintains the network topology, routing, and real-time decision about how the traffic will flow. Next is the management plane. So it handles the configuration, have the visibility and monitor and ongoing monitoring of endpoint of policies. And the last one is orchestration plane, so which manages devices onboarding, zero touch provisioning, and large scale policy deployment. Next we have the key mechanism for SD-WAN. So applications over routing, one of the first thing. So SD-WAN identifies application that uses a real-time link metrics like latency, jitter, packet loss, etc. And to route each flow along the most optimal path, ensuring quality of services. Then we have the dynamic path selection. So it continuously monitor multiple connections on which the SD-WAN has been configured. So it could be MPLS, it could be broadband, anything, and it manages the traffic for maximum performance and reliability. Next is the forward error correction and tunnel bonding. So this makes SD-WAN more resilient, combining multiple links from broadband and reliability with error connections to maintain performance over less reliable path. And then we have integrated security. So traffic is protected by this encrypted tunnels with policies and formats at the edge devices, and they have a secure gateway or firewalls which manage the overall security part. Okay. Now on this slide we will see that different type of SD-WAN architecture. So SD-WAN architecture, it can be deployed in different ways depending upon their key functions and what are the necessary parameters. So the first one is on-premises, the second one is cloud enabled, and the third one is cloud enabled with the backbone. So in the first picture that we have here, we can see this is the first setup on-premises SD-WAN, and it happens, it's directly at the sites. It handles the routing, policy enforcement, and controls locally. The advantage is direct oversight of data path, which means that traffic stays within the organization's boundaries and before reaching to the broader network. Okay, so this part here. But in this case, the control is localized at the local site, and that model can limit efficiency when workloads are heavily and cloud-based, and it will be also difficult to manage when cloud-based traffic will increase in a multiple geographically located locations. Okay. So in the second case, which are cloud-based SD-WAN, so we can see here that traffic is directed through a virtual gateway which is hosted in the cloud, and this allows branch locations to connect to either SaaS or cloud workloads more efficiently. So the control plane resides in the cloud as well, which provides centralized oversight across the sites. And the main trade-off is that the traffic to cloud service is optimized, but traffic between on-premises sites may not be benefited in the same way. Okay. So the third model that we have is cloud-enabled SD-WAN with a backbone. So on this model, it introduces a point of presence or the POP location that connects branches into a private backbone. So this POP lets the traffic exit the public internet earlier and ride a more predictable, lower latency path. So for example, a branch can forward traffic to the nearest POP location, which then uses the backbone to reach other regions. So this reduces jitter and improves the performance for the time-sensitive applications. The trade-off is dependency on the backbone provider coverage. So in summary, we can say that each deployment types reflect where the control and data paths intersect, locally on premises, in the cloud, or through the POPs with the backbone. Then the right choice depends on whether traffic is primarily site to site or cloud based or in global, and that's how we can decide the configuration further. That's all in the first part. I will for the rest of the topics I will put a new video soon And thank you all for watching. Subscribe for more upcoming videos related to networking and automations. And again, always share your feedback with us, and I will make sure that I try to improve what things are there I'm lagging. Okay, so thank you everyone. Chalo, bye.